Tuesday afternoon, 2:14 p.m., your phone lights up. The checkout endpoint just jumped from 200 milliseconds at P99 to 4 seconds, and the error rate is climbing. You open the dashboard.
Not even 2 a.m. this time. This one is happening while everyone is online.
Right. 3 pivot clicks. That is what turns this dashboard alert into 3 retries against a degraded replica. Metrics, traces, and logs are the 3 signals of any modern system, and each answers a different shape of question. 1 debug story, 3 tools, and the mechanism that ties them together.
So the first move is the dashboard, every single time. For example, take this incident. You pull up the service health page, find checkout, and there it is. The P99 latency line was flat at 200 milliseconds all morning, and then at 2:11, it steps straight up to 4 seconds. Right next to it, the error rate panel is sitting at 4% and climbing.
So in the first 10 seconds, 2 questions are already answered. Yes, something is wrong. Yes, it is bad.
Exactly. And on a good day, you also see which deploy correlates with the step. Metrics size the problem, name when it started, and quantify how bad it is right now. That sets up the obvious follow-up question. Which request is hot?
From that dashboard read, here is the trap. People think the dashboard tells them everything. It does not.
Yeah. The dashboard is great at telling you something is wrong and useless at telling you anything else.
Right. It told you the system is hot. It did not tell you which request is hot, which of the 8 services is the slow one, or what is happening to those failing requests.
Sure, 3 different questions, 0 answers.
Honestly, we have all spent 90 minutes scrolling dashboards before realizing we should have opened the trace view 40 minutes earlier. The official docs are blunt about this. I think that is the standard new engineer mistake, and now we can see why we need a different tool.
So you tab over to the tracing backend. You filter the request list, service, checkout. Duration, more than 3 seconds. The list comes back with maybe a dozen requests, all from the last few minutes.
Same time window as the dashboard, just sliced a different way. 1 row per request, not 1 number per minute.
Yep, you pick the top of the list, 4.1 seconds, 1 click. So what is in that click? Let's hear it.
From that 1 click, here's where it gets really interesting. Imagine a stack of horizontal bars. The top bar is the API gateway, 4.1 seconds long. Indented under it, the cart service, 3.9. Indented under that, inventory, 3.7. And indented under that, 1 tiny dark bar labeled inventory database query, 3.6.
Yeah, the first time you see a view like this, production debugging just becomes a different job. You sit there for a minute, it is that good. I think it stays that good every time.
Right. Each bar is 1 span. Parent on top, children indented beneath. Now the question stops being, is checkout slow, and becomes, which span ate the time?
So look at the math now. Total request time, 4.1 seconds. The API gateway adds basically nothing. Cart adds basically nothing. Inventory itself adds basically nothing. The 3.6 seconds is entirely inside that 1 tiny bottom bar, the database query.
Wait, so the inventory team did not even cause this?
Right. It is one specific call inventory made downstream, not the service itself. That is the kind of answer a metric does not give you. The dashboard would just say checkout is slow, and you would still be searching 40 hosts.
But the trace stops at 3.6 seconds in the database call. It does not say why. For that, you need to know what was happening inside that exact span.
Yeah, now you want the log lines for those 3.6 seconds.
And here is the cleanest move in the whole flow. The trace ID and the span ID are already in each log line because the logging library and the tracing library cooperate. They share context behind the scenes. So you click View Logs, and the viewer comes up filtered to just this request, just this span. No copy-paste, no remembering the timestamp.
And there are 4 lines waiting for you. The first 3 are identical in shape. Retry 1 of 3, replica DB, replica 2, timeout. Retry 2 of 3, replica DB, replica 2, timeout. Retry 3 of 3, replica DB, replica 2, timeout. The 4th line says, fallback to primary. Success in 12 milliseconds.
Oh, no way. So the story tells itself. Inventory tried to read from a degraded replica 3 times. Each timeout was about a second. Then it fell back to the primary, and that worked instantly.
Yep, 3 clicks. Total. Dashboard, trace, logs. 3 minutes flat. Compared to the 6 hours we used to spend grepping?
But notice what just happened. The magic move was not any one of the 3 tools. It was that you could click from one to the next without reorienting.
Yeah. Each click took the context with you. The same trace ID lived in the metric, in the trace, in the log records.
Right. That is the whole game. 3 shapes of question, 3 tools, 1 shared thread of identity tying them together. 6-minute debug instead of 6-hour.
So let me name the 3 shapes. Metrics answer, is something wrong and how bad? That is the smoke alarm. Traces answer, which path through the system is slow and at which step? That is walking through the building to find the room. And logs answer, what exactly happened in that step? That is the surveillance footage in the room.
Yeah. And the trap is treating them as interchangeable. They are not. A metric does not tell you which downstream call is slow. A trace does not name the error code unless someone attached it. A log does not let you count fleet-wide frequency on its own.
Exactly. Each one is a different kind of question. The pivot between them is the value. The signals are the inventory. The pivot is the verb.
And the reason the pivot works the same way everywhere is OpenTelemetry. The official docs name it as the vendor-neutral standard for emitting traces, metrics, and logs. Same SDK in your application code, regardless of which signal type.
The application stops caring whether the bytes leaving it are a metric, a span, or a log. Source links are in the description.
Same wire format, called OTLP. That gives you one shared protocol across all 3 signals.
From that unification, 2 words that get used interchangeably and should not be. Telemetry is the data your system emits about itself. The numbers, the spans, the structured log records. Observability is what you can learn from that data later, the practice of asking questions of it.
So you cannot really buy observability. You can only set up the telemetry that makes it possible.
Exactly. The tooling lets you ask questions. The asking is on you, which means a lot of engineers stop right here, and that is where the trap shows up.
Common mistake. Every new engineer says some version of this out loud at some point. I have logs. Why do I need any of this? And it is a fair question.
Sure. The honest answer is concrete. Imagine a new engineer on call who opens the dashboard during their first incident, watches the latency line climb, and burns 3 hours grepping 40 hosts before someone hands them the trace view. That is the standard story without these tools.
Right. Take a system that is 1 machine. Logs are enough. Take a system that is 8 machines. They are not. Without the trace ID stitched through each log line, the 3-click pivot simply does not exist. 1 machine, you grep. 8 machines, you need the pivot.
From that misconception back to the practical promise. Every production team that runs services, calling services, has the same 3 questions, and the engineers who can answer them in 3 pivot clicks are the ones who go home on time.
Next time, we open up what a span actually is, the atom of every trace, and the piece of vocabulary the whole rest of the series builds on. Thanks for listening to Learning Podcasts.